Hello, I'm Stian Soiland-Reyes from the University of Manchester. I also work for the BioExcel Center of Excellence in the EU. I'm going to talking to you today about the RO-Crate and BioCompute Object and how we can use that to describe and package workflows. Uh, First, I want to give you the annual reminder of the FAIR guiding principles. You may have heard them before, but if not, here's a quick intro. So this is a very influential paper published in 2016, which has since influenced a lot on funding and open science movement, and basically trying to change how we do something as simple as publishing data for our research. As you probably know, people are not always very good at this, but this paper sets out some good principles to follow. The the letters FAIR are actually an acronym standing for findable, accessible, interoperable, and reusable. But behind it, we have some actual principles that you can try to follow. So scientists are meant to make sure the data is findable by having metadata and data assigned global identifiers, which you don't throw away, keep them working. Having rich metadata to describe the data, and in those metadata, use those identifiers, right? Don't just throw them away. And you register this data and the metadata in some searchable resource or repository. To make it accessible, should be retrievable by the same identifier and using some standard communication protocol, which should be open. And this means sometimes the data is not available. Maybe it is just too big, or maybe it's actually not meant to be shared. It could be personal data and so on. That's okay, but the metadata must remain accessible even if the data is gone. Interoperability is key, so making sure the data and importantly the metadata is following some structured formal knowledge representation, some kind of syntax that the computer can understand, wherein you should use vocabularies so you agree about what the different keys mean in your columns and so on. And in there you should have some reference to other metadata where they exist. It's quite hard to follow all of these principles, but they are kind of guiding, so we should kind of move towards them. And this is to improve reusability of your data, and for that we also need to know the license, are you allowed to do it, and some attributes to describe it, like how large is the data set. Anyway, this was proposed for data, but now there's a strong movement to say this should be used also for software in research and also for computational workflows that are using that software. So you see here the idea of FAIR computational workflows, which we published just a year ago now in the Data Intelligence Journal, has now spun up several different workshops and independent projects starting up. And you see my boss down there in the corner, Carol Goebel, who presented a special theme on fair computational workflows in both ECCB and Workflows RI community. Anyway, so he's showing that there is an appetite for making sure workflows themselves are also shared using similar principles. So if we look at this, which is a paper for someone doing metagenomics, and I'm actually quite impressed of reading this, because here the authors have done exceptionally well in for improving reproducibility and explaining their methods. You see, I've highlighted in bold all the different tools they've used, which they've included versions and options and everything. This is unusual. You don't normally see that, right? This is very high level of detail. Yet, if I want to run the same workflow, I cannot click run on that paper, right? I will have to spend weeks, if not months, trying to build a similar workflows, installing the tools, connecting them up, and so on. And if you look at this particular paper, they've also shared the individual scripts and so on that they've used, but when you say workflow, it's actually just a shell script, right? That's the most common thing, right? That there is a shell script underneath. So if we think about that, how can that be described and shared using the FAIR principles? We would need some kind of overlay on top to provide that metadata, because clearly a few comments in there that just says analyze doesn't quite cut it. So this is the idea that made us come off the concept of research objects that started about 10 years ago now in the seminal paper linked in the bottom there, now led to lots of new work, which I'll tell you about. And the idea of research object is that you gather together not just the data, not just the CSV file, not just the log files, not just the scripts that made those CSV files, but you bundle all of these things together and you relate them to each other using rich metadata. So the metadata is key here as well. It's because each of them will come from a different place. They will have different authors, for instance, and one thing leads to another. And if you use a structured language for that, that means computers can understand it as well as machines, as computers and machines. Computers and humans, which we know are not machines, right? Yeah, RO-Crate is the latest evolution of how to express such research object. Because we talked about metadata, the way you need to write it down using a formal knowledge representation. So this is one of those. And it's actually built upon existing standards on linked data, something called schema.org, which I'll come back to. But really, it's a lightweight approach. Even though we're trying to use existing standards, we try to kind of hide most of those details. As I say, it's a community effort, so anyone can join. There's a large list of collaborators there. And so we're trying to just put together the best practices on how to write down formal metadata and make it fair, but also not just for describing simple data sets of a couple of files, but also large computational analysis. But what's in the heart of it? So I'm going to have to scare you a bit with something called JSON. You may have heard about it. So this is the web developer's favorite knowledge representation, if you want to call it that. Basically, it's just a key value pairs, and you can do arrays of those and so on. One problem when you're using these JSON, if you've ever tried using web APIs, is that everybody makes their own, right? So they all have different words they use, and so you're breaking that other FAIR principles about vocabularies, right? Because it's not interoperable if everybody makes up their own words. You just squash the text into something that looks like a structure, but where everyone is special. And that would make it very hard for something to do like find all the workflows which do genome sequencing analysis, right? Because if they all express it differently, you can't do that kind of program. So in RO-Crate, we are kind of locking down some of those aspects using something called schema.org, which is a large initiative which is actually used for marking up web pages originally. So it's led by Google, and it's what gives you that little search info box when you find a business or something. But it's a very large vocabulary of words, like the red things you see on the left there, which we can reuse also for data sets and for all kind of useful things, because it seems like we need many of the same things. Persons and organizations is an example shown here, right? So in RO-Crate, we separate between those two things because we have the data entities that are things we are describing, files and downloadable things in a sense, database and so on, and then contextual entities, things around it, things that have helped make it or other ways. And in RO-Crate, we basically tell you how to do those as what looks like specification, but this really is more like a guidance, best practice guidance, because we're showing how to use the existing standards, but in a very simplified way, which is easy to get started with. You can go on and do more if you want to, but you don't have to. You can just start with a simple thing. So we're kind of doing linked data, but you don't need to know, so we're kind of hiding some of those details. But an important aspect of that is also to have tooling, so you have software libraries to help you get along. And for most people are not developers, so they need something more clickety-click. And therefore, we have, especially the Sydney partners in this project, they have developed something very cool called Describo, which is a desktop application for doing that simple use case of just putting together a couple of files, describing them, hence the name, and also linking in authors, publishers, and so on. But you can click the blue buttons and add in additional things as well. So you can go kind of off-piste if you want to. And that's a kind of easy-going way to get started with making an RO-Crate, and you're making formal metadata at the same time, which you can then use with the other tools, which I'll show you a bit about later. So here's a similar one, which I've just started just like a month ago, called Describer Online. So this is a kind of web attempt to do the same thing. It's actually a bit more general, because it now handles all kind of types, but not just the prescriber one that we have listed in the RO-Crate pages. Now here you can use the OneDrive is the starting point here, because in University of Technology Sydney they just said the data repository is just a OneDrive. We're paying for that to Microsoft anyway. Just put all your data there. Of course, there's no metadata in there. People have very weird file names and so on. So if you just overlay an RO-Crate in there, you can describe your data and connect them up together. And it's now taken up by a further EU project to connect to other cloud providers. Now, here's a very interesting project which uses RO-Crate, but you don't really see it. So there's something called Paradisic, which is digitizing cultural records. So we're now into digital humanities. There's no molecules inside, and and in here we find that you're finding all these recordings of people speaking their native languages and so on, and you have transcriptions of those. Digitize those, you get lots of different files with different attributions and different types and so on. And to formalize that metadata, you have to have quite a bit of structure, because you want to keep them separate but merged together in a way. And that's what they've done here. But actually, beneath the hood, it is RO-Crate, yeah? But you don't see it, right? Unless you click the secret button in the corner. So you see that kind of metadata shown here is actually extracted out from an RO-Crate. Now, it didn't start as RO-Crate, but they converted it into RO-Crate so that they have actually preserved their metadata. Because they said an important aspect for them was not just to make a lovely portal, but for all that rich metadata to also be preserved, even if they stop using that portal, right? So you want to make the metadata fair as well, right? So this is a project that I've been working on in Manchester and several other EU partners, something called Workflow Hub, which we're quite excited about. It's fairly new, so it's just starting to fill up now. It's a repository of computational workflows in life sciences, where you can register your workflow no matter which language it's implemented in. We also catalog existing repositories. And one challenge we had there was to support the many different workflow languages, and they often don't have much support for metadata. Even simple things like, who's the author of the workflow, it's not going to say in there, right? So we need some way to capture that metadata and keep it. And also, some workflows are not just a simple file. They're a set of different files working together, just like in programming languages. And again, they can have different attributions, different provenance and file types and so on. Because if they're good, they're actually reusing each other's work. But then, of course, you should be seeing again your name and the things that have been reused. So it's many of the same challenges we saw before with the cultural heritage example. So if you just look into that, here's in Workflow Hub how a workflow has been uploaded, and then you get the diagram for it, you can see, and then metadata is shown on the side. So for the user, you can see all these things. You can fill them in and so on. And also the inside of the workflow, maybe description of the steps and so on. But actually, if you click the button to download the RO-Crate or use the equivalent API to do so, you will find the structure metadata is also available, where hopefully all of this information is also captured. I will admit not all of it is in there at the moment, but most of it should be. But now we're also looking at doing that also for registering workflows, right? So not just to show share the workflow metadata out again, but also to reuse such structure metadata from the outside. So you can maintain it separately on the outside in GitHub. So this is something we're doing in the PyXL project, because we have some real-world workflows doing COVID-19 analysis on supercomputers, and this is not so easy as the previous example, because here you have multiple files with different options and so on. So here is actually a whole GitHub repository just for one workflow, and that's a very common approach that we see now, that people maintain workflows as if they're source code. So that's a very promising development, and I'm very happy for that because that's not how it was 10 years ago. But we see here that the RO-Crate is useful because you can describe all the other files in your repositories. Because if you have more than 3 workflows, where do you start, right? So you need to know that kind of thing. And that's why we have an advanced upload where we can do that. And then keep it in sync, so you don't need to go and update anymore. Still work in progress, because people will try to break this in different ways. Now, to make these kind of platforms, you need good software libraries. So I'm not going to say they're good. You see, we have version 0.2, but they are maturing a lot, and we have for several programming languages, and that is helping a lot, this kind of development. And that's another aspect, is that FAIR is not just for machines. We talked a lot about the machines being happy, but or the developers being happy, but most people are not, right? They just want to read text. So if you have all this metadata structured, there's a lovely tool that can called RO-Crate HTML, again from our Sydney partners, who will render it for you as a kind of table-based thing. But here you can click into individual things, so you can go and explore one by one of the resources described. For instance, here on the right, you see we clicked into the chipsec example, and we can see the individual orders of that particular file, but also links to how it's related to other resources. It looks interactive, but it's actually a single HTML page that just reads that JSON file, and therefore this can also be stored and preserved, not for eternity, but for as long as we have web browsers, and so you will have this living along without any infrastructure running. Now, let's move on to BioCompute Objects, because that's really why we're here today. You might have remember several talks about the BioCompute Objects before. They have been standardized, right? So IEEE have, working with IEEE, we have made a standard called 27912-2020, the year we all want to remember, right? And you can go and download the standards if you pay or have access, but you don't really need to, because most of the definitions are actually shared open source in the JSON schemas. So this is what the programmers want, because here you can see all these keys that we talked about, but for BioCompute Objects, they're already formally defined in there. Now, so the old name BioCompute Objects, that's now, we can think of it like Wi-Fi versus 802.11, so there's a formal standard and a word for it that is more like a colloquial name, but it's also the user community. So we have regular meetings and so on, and there will be lots of documentations and tools and libraries and so on, those kind of things for BioCompute Object. Now, here you see some JSON for BioCompute Object. It's not meant to look like that, because it's a bit too much to look at as a human, right? So the computer is meant to look at it. I'm going to insert a nice picture with colors in here, so you can see that, which separates the different domains. So the key concept of BioCompute Object is that you have provenance domain, usability domain, description domain, execution domain. Is to describe different aspects of a workflow, essentially, right? So you say, where did it come from? How do you run it? What does it need? What is it actually for? And that's very important to know, what is it really useful for, so you don't run it, on the wrong species or something. And what I'm going to look at today is how to combine these two standards, right? Because they look like they're doing the similar thing, right? It's about describing things, but not quite the same way, right? So what we're talking about is how to put BioCompute Objects into RO-Crate. So making some kind of package of the BCO. Now, why would we want to do that? Well, the BCO itself is just that JSON file, right? It's just a description of the workflow, but I mentioned there are also all the other files which we may want to talk about. So we'll come back to that in a minute. So let's pick a use case. So here's one that we use, which is just gone a bit off piste, go to a bit of things unfamiliar to me, which is the Nextflow workflow system, which has nothing to do with me, and therefore I'm a bit more neutral to it, but it's a very nice workflow system which is very popular for running, particularly on the cloud, things like next-gen sequencing pipelines. So here's something interesting called NF Core, which is a collection of kind of standardized workflows that are very well maintained by a community of developers. So let's just imagine someone wants to submit one of those just straight into FDA, right? It's probably the wrong, biomedically it's probably wrong to use this particular workflow, but I like this particular workflow because it's really nicely documented, right? So you see all the different steps are well documented on the web page. You can see the outputs, what are they meant to mean, and the individual parameters you can set. And in many ways, if all workflows were described like this, you probably didn't need the BioCompute object, right? So part of the reason for doing BioCompute object is to force that kind of information out of people, right? So there's a blank slot that needs to be filled in. Because you can imagine generating this kind of output from those fields in the BioCompute object, and therefore the users would have to fill it in so they don't get empty sections. So I want to use this as an example for making a BioCompute object, which I'm then going to wrap in the RO-Crate. And I like this workflow because I can just pick up all the information from here. I don't have to use my own workflow, which I know too well, and which I will just fill in things out blank. Here we already have the information. And it's nice for testing because you can just run it on the command line if you have Nextflow installed. There's no additional steps for getting it ready. So it's good for getting started with as a tutorial. So this is what we built as a tutorial for how would you do this yourself given that workflow. So once you learn to do it with that workflow, you can hopefully do it yourself with your own workflow. So this we have published on the BioCompute website, and the way we start is basically step 0 is install a workflow engine. Because we're using Nextflow, most people maybe are not using Nextflow, so we will have to show you how to get started with that. It's just 2 command lines to run actually, but it depends a bit on your machine how to do this particular step. Usually most people know how to run their own workflow engine, so when you want to do this with your own workflow, you don't need to do this bit. But a good question is, how do we capture this information in BioCompute or RO-Crate level? Because there's no slots for this at the moment for how to get the engine for running the workflow ready and running in the correct version and so on. So in the tutorial, what we're starting with is just some kind of skeleton things, so showing how to make these JSON files. So kind of like giving you an empty template to start with, and how you fill in all the different things. And as we're working along, we're filling up this data directory. And we'll come back to this later, why we call it data. It's not all data, but that's the name we're using. And so we can think of the BCO as describing a workflow as a true and exemplar run. So this is why we're going to run the workflow, because in BioCompute object you talk also, just like you saw on the Nextflow website, about inputs and outputs. And the easiest way to talk about outputs is to have some actual outputs to show to. And that means you need some example inputs to run it with. And luckily we saw that workflow had that. But before you even start, we can talk about the workflow definition, the script that you're kind of running, right? And that goes into the provenance domain of BioCompute object. So you see in this tutorial, we do have to cover some aspects of the BCO as well. So there's also kind of a bit of a tutorial for how to do this with the BioCompute object. Because we'll come into some questions on here on who do we mean, who made what. For instance, I'm using this workflow from NF Core, which I didn't write, so I should acknowledge the original authors, as you see I've done here. But where do my name go though? I'm not an author, but I help create this BCO. I didn't put the knowledge into it, but I helped putting it together. So already you can see how these slots, by being flat in the BioCompute object, can get a bit squeezed. And this is why I want the BCO to be focused on the workflow, because that's really what the BCO is describing, and not all these other things we have around it, like the data files and so on. So it's worth to point out that BCO do allow you to specify different roles of contributions. Like you can distinguish between someone who authored, someone who helped make the knowledge, versus someone who created, maybe just made the files or saved it at a particular format, or even someone who has been curating, reviewing something, or importing it, moving it from one place to another, or just retrieving. And these different types of roles you can specify at the BCO level. and that's quite powerful for this particular use case where we have different people, different organizations who are contributing in different ways. Yet a BCO still deals with the workflow and the BCO as single submission. And if you wanted to break down further, like saying how who made a particular data file, then you need to go into RO-Crate level. So that's where the RO-Crate kind of complements the BCO, in that instead of focusing on the different roles, you can specify on the different things that have been contributed and attached people and organization at that level. So you see these both different approaches may be represented the same contributors, but in different ways and a different perspective into their contribution-ships. And similarly for RO-Crate, we make a skeleton. The skeleton for RO-Crate is quite small, but still a couple of lines, and that is because the first thing an RO-Crate always does is to describe itself. So following the FAIR principles, it should also self-identify, so we know what it is, and basically says I am an RO-Crate, right? So we have different versions, and so we say which one we're trying to be. It may not be true, but at least you know what it's attempting to comply with. So in the tutorial we look a bit about how you fill in these different bits of the RO-Crate and the BCO in tandem, bit by bit. Sometimes there are overlaps, but actually there are differences. For instance, we come back to author. The data set, this RO-Crate, the collection, the author of that is whoever put it together. So that's where my name can come in. So you see I put my identifier in as an author here. And again, we can have a different license for the package rather than an individual file in there. Sometimes we have a mix of things, and that's okay, because in RO-Crate we can override these under individual nodes for each of the files and say, actually there's a different license here, there's a different author for that. And so you can provide additional metadata for each thing where you need to. So the tutorial then goes on to how to run the workflow, and this is where we thought it was easy because it's just a one-liner from Nextflow. They were very helpful. So all the test data just comes in and it just runs, and it will take a couple of minutes to run, but while it's running you can fill in the BioCompute object. But then you get some questions like, well, what about all this test data? And I should be declaring that in my BCO, should I not? Right? And therefore, where do they get from? Luckily, there's a log you see in the corner there. We get some URLs coming out, which you can click on, and that's how Nextflow fetches the data. And so those fit perfectly into the BCO. And luckily, they also fit perfectly into the RO-Crate, because in both cases, we're using URLs as identifiers. And that's basically making linked data. It's just identifiers you can click on. So sometimes you have to decide on your own identifiers because you're making new data in your run. The easiest is just to refer to them locally in your folder paths. Sometimes that doesn't work because they're too big, or we're not allowed to share them, that kind of thing. When I did this, one of the big data is 100 megabyte, one zip drive, right? Because GitHub doesn't allow more than that. So then we had to do external references for those kind of files. That raises new questions, so we address a bit about that in the tutorial as well. So what about the results? When you get them coming out, you may want to do this description of them. In RO-Crate, it's not a manifest. You might think of it like it is, but it's not. You don't have to declare every little file you have. But you can declare folders, right? So in this case, we just list the individual folders, which corresponds fairly well to that documentation pages we saw on the NF Core website, which means we can fill in that kind of description for each of those and talk about a group of files together. Or maybe we should just link directly to the existing documentation. You can do both. But when you do these things, you need to refer to things on the outside, things that are not captured, things that are not files, or at least not files within your package. Those are contextual entities, things in the world, you can think of it like. And they could be living things like people or organizations, or it could be software. Particularly here we want to say what kind of, that we use this particular Nextflow version to run it, and the workflow itself is a piece of software. And the next one example here is interesting because the workflow definition itself is also downloaded on demand, which means we need to capture which version was it downloading. And both in BCO and in RO-Crate have slots for that, but in RO-Crate you're allowed to add additional things because you have a whole object for that software, so you can fill in who was it published by, for instance, or what date was it from. So you can fill in as much as you want or as little as you desire. You can explore further. So in a sense, you can think of our tutorial as a kind of meta guide, because we're just saying what you could look up for in the other documentation. And maybe it's sufficient to just build it on the examples we have, but you can go further in when you're special, right? When there's something extra you want to do, like publishers or funding, equipment, and so on. Finally, the tutorial is showing how do we package data up, how do we actually put things together, because when we draw this lovely box, what does that actually mean? Is it a zip file? Doesn't have to be. I think often we don't want a zip file. Maybe we just have a collection of files, but that raises a big problem of how do you know even all the files are there? Did I copy them over correctly? Did I mess them up in my editor? What happened, right? So when these things are moving around systems, especially when they're not in, say, a Git repository or something like that, you need some way to make sure they are complete and not changed. And again, we'll be using existing standards. We're using Bagit, which is a way of just capturing checksums of files. And here you go, a manifest. So the manifest file for a particular checksum will just have checksum, some hex numbers, and the file name. So you can see that all the files are there and that they haven't changed. And there are existing tools that can make and check these things for you. So then you know all the files are complete. You can think of this as a kind of distribution layer. And in fact, there is also a mechanism in Bagit to have, they call holy bags. So there's holes in the bag where you don't include all the files. So you can exclude certain files, maybe because they're big or requires authentication. And that's something you can read about in a big data bag paper linked in the bottom there. And we have not explored this yet with the BCOs, but of course it should work with them as well. The question then is, how do you archive certain data out before you publish your shrunk bag in the end? But the tutorial will show you how to get started with it as an easy way without necessarily using all these tools. Now, when you have this RO-Crate, as I said, we also want to keep the human in the loop. So we're showing you how to make this human readable version of the RO-Crate metadata. And this is the same as I showed before. But once you follow the tutorial, you will also be able to make that. So we're talking about separation of concern, because we have all these different standards we're putting together, just 3 of them really. But at first it seems like that is complicating the picture. Why can't we just do it all in one go? Well, one reason is so we can reuse existing tools, as I said. Each of them have a good collection of tools. The other is that it's already been figured out, why not just use the existing way of doing it. So for instance, Bagit is capturing only the checksums of the files, which is really good at. We don't want to reinvent that. You could, in theory, put metadata in there, but it's just the key value pairs, or they're kind of very loose, so it's not really suitable for much structured data like we're trying to do here. The RO-Crate level is kind of describing an individual data files and the other things in the world, as I said, relating them and typing them. So it's putting connections between things. It's not explaining the inside of things. That's the role of the BioCompute object, at least for workflows. So you can say, what is the workflow for? What does it consist of? And then, of course, you have the data itself, which we also include, and the workflow itself, which could be by reference, it could be as a file inside, it could be as a URL, which it is in this case. And of course, you can do this for any kind of workflow system. We just use Nextflow because of the documentation we had there. Personally, I work more with CDRL, Galaxy, and Jupyter notebooks. You're going to find all kind of workflows coming in through your BioCompute objects. And so we think of this layering here as doing different aspects of putting things together. So what is the next steps now in the BCO RO-Crate? Well, we want to get more feedback, right? Because now we just kind of come up with this thing and put it together. We want to test this to make sure it makes sense, and try to also do this with a not so ideal workflow, one that is not so well documented, where the BCO and the RO-Crate will be do the heavy lifting of carrying all that description, and maybe then you can generate the human readable views from that. And there's this tension between how much can you collect these annotations manually from people and how much can you generate automatically. For instance, a good workflow system will know what are the list of steps in it, but how do you get that extracted out and get it into the BCO? Do you have to do individual parsers for each workflow system, like we've done in Workflow Hub, or is there a better way? We're also looking at interactive approaches. Like now, this tutorial is very based it's kind of targeting developers, right? So we are kind of a bit in the command line, a bit in the JSON, that kind of thing. And as I said, the other people are not so familiar with that, and that's not really a good way to throw people into making this. It's a good way to scare them off, actually. So we have all these desktop tools that we talked about. The BioCompute Objects also have BCO editors, which you can use interactively for making BCOs. So now that those tools have matured at the same time, it would be good to do a graphical version of this kind of tutorial, and also about how to consume them, which I think is more important for the regulators, because you will just be receiving these RO-Crate with the BCOs inside them and then thinking, what do I do now? You don't necessarily want to make a new one. You want to consume the one you have. So you could focus more about how to browse them. Maybe if there was no human readable equivalent, how to render that using these tools like Calcite. Also looking at project integrations. I talked about Workflow Hub, and it doesn't have any BCO support at the moment, but if there was, we could pick up all those lovely things we want to render, right? Of course, me being at 1 foot in both ends, I can help with that. We also work closely with the Common Workflow Language, and again, Common Workflow Language, one reason why I did not use that in this example is because it already has lots of good hooks for metadata. It's the odd one out, right? So in a sense, again, that almost does not need BCO, almost does not need RO-Crate, but most workflows are not like that, right? And even if the hooks are there, people don't fill it in, right? Similarly with Galaxy, and we know we already have worked with making BCOs from Galaxy. That is kind of standalone at the moment. It's kind of web-based, so the BCO is kind of trapped on the web, and which is nice as for linked data, but it's a bit fluctual, right? You cannot just fetch the whole thing. So there's another role for RO-Crate in there to package up all the results of your Galaxy workflow with the BCO on the side and the RO-Crate descriptions generated from within Galaxy. And then you would need to complete a few things to make it fulfill the purpose. So that concludes my talk about BCO RO-Crate, and I would like to thank you all.